Hello my dear students, welcome to my channel AIPMT. Today's topic is haloalkanes. Haloalkanes. In this topic we are going to discuss about the preparation of haloalkanes, how haloalkanes are prepared. Let's come to the preparation and come to the topic haloalkanes. Today's chapter is haloalkane and haloarene. Now I am going to discuss about the alkyl halides. What are alkyl halides? Now the general formula of alkyl halides are X, where X is the halogen atom. Halogen atom means there are 4 halogen atoms. Those are chlorine, bromine, fluorine and iodine. These are 4 halogen atoms. Symbolically, this is represented as X atom. So, the alkyl halides having general formula, having symbol is Rx and general formula is CnH2n plus 1 and X atom. When one hydrogen atom from an alkane is replaced by an halogen atom, then alkyl halide is formed. Here, I am going to discuss about the overall preparation of alkyl halides, how alkyl halides are prepared. This preparation is very important for your syllabus and for your course, and also these reactions are important for your preparation for NEET, JEE and medical. For all the students, these reactions are very important. So kindly see this reaction and try to understand all of this. Now alkyl halide. How alkyl halide is prepared? The preparation of alkyl halide. How alkyl halide is prepared? The preparation of alkyl halide from hydrocarbons, those are alkanes and alkenes. Alkane is the saturated hydrocarbon and alkene is the unsaturated hydrocarbon. From alkene, how alkyl halide is prepared? From alkene, when alkene react with chlorine or bromine in presence of UV light, ultraviolet light means sunlight, the alkanes react with chlorine and bromine in presence of UV light prepares alkyl halides. So likewise from alkenes, that is symmetrical alkene and unsymmetrical alkene. What is symmetrical alkene? Symmetrical alkene means the carbon and carbon atom double bond means alkene group. Here if the carbon atom containing to carbon-carbon double bond, the both sides of a carbon-carbon double bond, the carbon atoms are same. Means the carbon atom or the alkyl groups attached to the carbon-carbon double bond is same. Number of alkyl group is same. Here is one alkyl carbon and here is another carbon. Means the carbon-carbon double bond is attached to same number of carbon atom in both the sides. So this is known as symmetrical alkene. Symmetrical. And unsymmetrical means the opposite of this symmetrical. Means if here this is carbon-carbon double bond and in the right side of carbon-carbon double bond I write that is CH2 CH3, and in the left side of a double bond I write CH3. So here the carbon-carbon double bond is this group, and in the left side of carbon-carbon double bond one alkyl group is attached, and in the right side of carbon-carbon double bond two alkyl groups are attached. So this is called as unsymmetrical alkene and this is called as symmetrical alkene. For symmetrical alkenes, if the symmetrical alkenes attacked with hydrogen bromide, then it forms alkyl halides. And for unsymmetrical alkenes, unsymmetrical alkenes. There are two rules to form alkyl halides. First is Markovnikov's rule. Here in Markovnikov's rule, when alkene react with the hydrogen bromide, it forms alkyl halide. And in Markovnikov's rule tells that the halogen atom of halogen acid means hydrogen bromide attack to the less number of hydrogen atom containing carbon atom. So this is the statement of Markovnikov's rule. And alkenes react with hydrogen bromide in Markovnikov's rule, it forms alkyl halides. Likewise, another rule is there, that is anti-Markovnikov's rule or crash effect. What is crash effect? Now when unsymmetrical alkene reacts with a hydrogen bromides mean halogen acid in presence of a hydrogen peroxide H2O2, that forms alkyl halides. Now go to the alcohols. How alkyl halides are prepared from alcohols. From alcohols, when the alcohols having general formula ROH. Alcohols having general formula ROH. When alcohol means R bond OH. When alcohols treated with halogen acid means HX, X for halogen atom, halogen acid in presence of a reagent, that is anhydrous ZnCl2, it forms alkyl halide. Second is when alcohol is react with phosphorus trichloride or phosphorus pentachloride, it forms alkyl halides. And third is when alcohol is react with thionyl chloride means SOCl2. Thionyl chloride, the symbol of thionyl chloride is SOCl2. Then it forms alkyl halides. And the last is when alcohols react with phosphorus tribromide and phosphorus triiodide, it forms alkyl halides or haloalkanes. Here phosphorus tribromide and phosphorus triiodide, these are unstable. So these are react with a red phosphorus reagent to form alkyl halides. Besides these, there are other reactions to form alkyl halides, that is halogen exchange. Halogen exchange means exchange of a halogen atom, means when an alkyl halide is treated with, means alkyl halide means Rx, is treated with sodium iodide, means sodium iodide in presence of dry ether, it forms alkyl halides, means alkyl chloride. We can take an example of alkyl chloride. When treated with sodium iodide, the halogen atom is exchanged, means it forms alkyl iodide plus sodium chloride. So this is a name reaction which is known as Finkelstein reaction. This comes under halogen exchange. Exchange of halogen atom. Here iodine is the halogen and chlorine is the halogen. So both the halogen atom are exchanged together to form alkyl halides. Another reaction is SWOT reaction. Here the fluorine atom containing metal, fluorine, the halogen atom fluorine that contain the metal atom means metal fluorides. Metal fluorides are exchanged with alkyl halides, other alkyl halides to form alkyl halides. Here, if we take an example, that is alkyl chloride plus silver fluoride, it forms, here chlorine atom is exchanged by fluorine atom, it forms alkyl fluoride plus silver chloride. This is the alkyl halide group. This reaction is known as SWOT reaction. these reaction, all these reactions are comes under alkyl halides preparation. The preparation of alkyl halides shortly explained by these tricks. Now I am going to explain the how to write a chemical reaction by knowing their reactants and products. See, if we know that when alkyl halides, if we know the reaction, that is from alcohol ROH plus thionyl chloride SOCl2, it forms RCl plus SO2 plus HCl. This is the reaction. How you write the theory of this reaction? By knowing this simple trick you have to follow. This is the symbol of alcohol. This is the symbol of, the name of SOCl2 is thionyl chloride. The product side, here it is the reactant side, and here these are the product side. This is alkyl halide, or means alkyl chlorine means alkyl chloride. This is sulfur dioxide, and this is hydrochloric acid. The important part is the reactant, the reagent and the product. Remember these three parts. The important part is the reactant, the reagent and the product. And if there is any catalyst used in the reaction, so remember this catalyst. Now you have to write the reaction. How you write? See, write when, first write when. This is alcohol. When alcohol is treated with, whom alcohol is treated? Thionyl chloride, means thionyl chloride. Alcohol is treated with thionyl chloride, or you can write SOCl2. Symbolically you will write SOCl2. When alcohol is treated with thionyl chloride or SOCl2, it forms the product, that is, it forms the product alkyl halide or alkyl chloride. With the release of sulfur dioxide and hydrochloric acid. You may stop from this reaction, that is here. You may stop your writing from this to this. That is, when alcohol is treated with thionyl chloride, it forms the product alkyl chloride. Or you may explain this reaction. This is the trick how you can write the reaction, the overall reaction, how you can write. This is the simple trick from remembering the reaction to theory. You can also remember the theory and write the reaction. Likewise, I am giving an example. See, if you know the theory, that is, when methane is treated with treated with chlorine in presence of UV light, it forms methyl chloride. How you can write the reaction from the theory? See, the formula of methane is CH4, means methane is the reactant and methyl chloride is the product. So when the reactant species means left hand side, the methane is treated with, means react with chlorine. So methane is CH4 plus chlorine atom, means chlorine, in presence of given arrow, and write the reagent in presence in above the arrow, UV light, or you can write H nu, means UV light. So it forms methyl chloride. The symbol of methyl chloride is CH3Cl, and also it releases hydrogen chloride. So this is the reaction, that how you can write reaction, chemical reaction from the theory of an organic compound. So they write the name of the compound, that is methane, and here it is methyl chloride. This is the overall reaction of the compound, and this is the total preparation of haloalkanes. Thank you all my dear students for listening and for watching this video. Stay home, stay safe, like, share and subscribe this video. Thank you for your love and support. Thanks.
Actually, while I am typing this program, suddenly